In this video, we are looking at how to represent music with PWGL. In the end, what we want to do with PWGL is write our own computer programs that then compose music by themselves or that help us as our little digital assistants in our composition process. And in order to write computer programs that output music, we need to first understand how we can actually represent music. And so that's what we look at in this video today. We already looked in the last video at some example of a editor, a music editor, that was a chord editor. And you'll remember that we can represent individual notes. Yeah, what we did was just brief rehash, took a number, for example, middle C, 60, or say 62 for D, imported that into the chord editor, evaluated the chord editor by pressing V, and there we go, and we can play that. And we also looked that we can actually have a list. Yeah, I go to data and use the value box, data value box, in order to enter a list, a sequence of numbers. Yeah, for example, what I did was enter 60, 64, 67, which are the MIDI note numbers for middle C, the E above middle C and G. And if we connect that to the chord editor, then we get a chord. Okay, now that is a chord. That's one way. Now we look at the second editor, again under editors, and here is a score editor. And if we take the same number sequence and enter that into the score editor now and evaluate that, then you see with the chord editor we get a chord, and with the score editor and just a plain sequence of numbers we get a sequence of pitches. So this tells us something very important already, namely that some representation we have, in this case a list of numbers, what it actually means depends on the program you write. This is not that this always means it's a chord, or that it always means it's a sequence of pitches in the melody. It can also mean something else. It depends on our program you write. Okay, now some of you might feel uncomfortable with us using these music notation editors here. And so here's the good news, that there is a way for you who prefer to have some MIDI roll notation, that yeah, we can have that as well. Here's this 2D editor. Just move everything a little bit up here. By the way, if this window gets too small, yeah, we can also increase that. And if I take the chord, not the pitches, but the chord, and enter that into the 2D editor and evaluate that, then you see we have some picture here of the chord. I can also play that. Likewise, if I take the score and enter that, if I go hover with the mouse over the virtual patch chord, I can move it around like that. And your virtual patch chord by default may look a bit different, depends on your settings. If you want to change it, if you control click or right click on the chord editor, there are some ways to look at different representation, like for example line. Anyway, just a side remark, if I'm evaluating now the 2D editor, you see I have basically, yeah, you can think of in Logic, you have the MIDI note representation, the piano roll notation. Yeah, this is basically a piano roll notation. If I open this, yeah, perhaps it's a little bit more clear that this is our note 60, this is our note 64, this is our note 72. Yeah, so those values are not quite helpful here because they are fractional values. But anyway, if you just look at like this, then you might feel okay. For those of you, only for those of you who are not having difficulties with music notation, there is an alternative to read a score. Okay, now we had a sequence of pitches representing a chord or a sequence of pitches representing a melody. But if you look at this a bit more closely, then you can see note values are not quite properly notated here. We have no way, for example, to specify this is a longer note, this is a shorter note. Yeah, even if I have this, if I make this a bit longer, just for argument's sake, turn this in a little melody. Say, yeah. Yeah, so then there's no way for me to easily change the durations of notes. So how do we represent rhythm? For rhythm, there are ways to represent that directly into the note editor, and there are ways to directly express that within PWGL, but actually that gets a bit more difficult, and in order to avoid such difficulties, we use some extension. And there are different extensions we could use for that. We are opting for one, which is developed by Urgent Sundred, developed for his students and his own use there. Library, sorry, I didn't mean to have that. I instead meant to go here and say go to load library. He developed a library called Flat, which is the name of the studio where he's teaching. And if we go to File, Load Library, and then scroll down to the respective library and say, okay, then that library is loaded. And now if you go to this menu, you see there's a new entry in the menu where you can load that note. You can only do this once you have installed that extension library. We are covering how to install extension libraries somewhere else. So yeah, I'm just assuming at this stage that you have installed that. So once you have that, and we go here into the entry score, and there's an entry called simple layer to score. That is this box. And we will use, sorry, I didn't mean that. I just meant to make the whole thing a little bit bigger. We will use this box to enter a rhythm. So we take another score editor, editors. Now we know score editor, and I connect the score editor here. And now I'm taking another value box in order to enter some rhythm. Let's see, I want to have a rhythm like da, 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 very straightforward. And I say this is a beat, quarter note, quarter note, quarter note, now two half beats, da, da, eighth notes, and another quarter note. And the quarter note is represented here by a quarter, the fraction quarter. Here's another quarter note. Now we have an eighth note, another eighth note, and a quarter. And I close the parenthesis and close the whole box. So just to see, yeah, da, 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 da. And I connect this to the entry of the box called rhythm. And if I evaluate this now, then you see we have exactly that rhythm which I just sketched or suggested in there. Now what we don't have here is any pitches. Pitches would be entered here. We do that in a minute. But as there are no pitches right now, I just increase the size by zooming in with my trackpad. You can see these pitches are just those crossed out notes. They are currently just missing. We can change the time signature. This time signature currently means 4/4, which we have there. If I, for argument's sake, for example, change that to 3/4, then the time signature here changes into 3, 4. And now we want to turn that into a melody, and one way to turn it into a melody would be to add some pitches, and pitches are represented here again as MIDI note numbers. So I can just take the pitches I had before and connect them in here. I likely only need to make sure that the number of note values and the number of pitches match. So in this case it's 1, 2, 3, let's see, 1, 2, 3, 4, 5, 6, 7 notes, and there are 1, 2, 3, 4, 5, 6, 7. So it happens that it matches. And oh, actually it doesn't quite match. I miscalculated that, and therefore in the end you see it just doesn't know the pitch and just ends that number. So if I very slightly change this by adding another value here, for example, after the G I add the D, and we do this again. Sorry, do this again. And you see we have a little melody, and the melody has been represented, the rhythmic values by fractions and the pitches by MIDI note numbers. So now we are at a stage where we have some music representation which is complete already if we only want to have notes and no dynamics, no articulations. That is much more difficult to do here in PWGL, so therefore for most of our time we will actually focus on having only this. The only thing, so to speak, missing now for writing our own computer programs that generate music would be to generate those number sequences. But at some stage we might want to have polyphonic music, so let's turn that into some result where we have more than one voice. So for that I select the box simple layer to score, and you see that box has a little, at this corner has a little, an arrow, and that arrow indicates this is an expandable box. All the boxes, and there are quite a lot of them, so just for argument's sake I'm showing you another one. If I'm going to list, for example, and go to the number called list, the box called list, you see the same arrow, or yeah, there are loads of them. Those boxes can be expanded by a shortcut, and the shortcut is basically pressing plus. But if you want to press plus on a standard keyboard, then the plus, we usually just write shift and then take the key where the plus is on top of that. And you see, then we have another layer. If you want to remove that, make it smaller again, we just press minus. We could also press plus on the keypad, and then we don't need to have the shift there. Or minus to remove it. Okay, now we want to have that. And for now, for argument's sake, just let's have exactly the same pitches and rhythmic values for the second voice. Yeah, so they are in unison. They are exactly doing the same, both voices, both parts. And make the score a bit bigger in order to actually make sure, now we need to make that a bit smaller. I do that, the zooming in and out on a trackpad by the usual pinch movements. If I want to make sure I actually see multiple voices, then we need to do one little more step here, and that is change some default setting of the score editor. By default, unfortunately, the score editor only shows one part. If I evaluate this just to show, then you see it doesn't show the second part. If I double click on open it, then voila, there we go, there are actually two parts. It doesn't show it here. So what I need to do is I control click or right click into this box and then go to the setting edit input box, and there I can tell it the number of parts, and you can make this a much bigger number. I'm not sure why it didn't make this by default number of parts, and if I press OK, now we can see both parts here, and now I can make this a bit. Oops, come on, zoom in again. So in playback wise, that doesn't make a difference because they are both exactly the same parts. But yeah, once we have now this setting, we can also change that by having slightly different, say the same rhythm, but different pitches. I just copied that box, Command C, and now I pasted Command V, and I have a second box now. Unfortunately, it's directly beneath, so that's a bit tricky to grab sometimes. And I can put that in here. And now I could enter different pitch values. For those of you who are uncomfortable with reading standard COM music notation, I'm going back and offer that we have this 2D editor here to enter the score. So the score output goes into the 2D editor. And so this looks now, usually the output of something should be either to the right or below. That makes it a bit more difficult now to read, but yeah, we can see now this is one part, this is the other part. Very simple, just some harmony. Okay, now what we covered so far was how music is represented, how the rhythm can be represented, and how the pitches can be represented by numbers and by sequences of numbers, by lists of numbers. And that can lead us now directly to creating our own computer programs that generate those number sequences, because then we can actually generate our own music.